today we're going to be talking about the OSI model, brought to you by myself and Justin. Oh, you're muted, Justin.
Sorry about that. Hello, fellow students. Me and Zach decided to do a little presentation on the OSI model, which is a great segue to what Darian and his buddy there, Sergio, were talking about. It's I think learning about the fundamentals of networking is super important, and I felt like it was a great opportunity to talk about the whole picture of information technology. Software is just AKA programming. It's just deals with some of the aspects to the bigger picture. So, so the OSI model is just a collection of protocols that allow computers to communicate. OSI stands for the Open Systems Interconnection and was created, standardized these protocols, and allows communication around the world. The DoD created a competing open networking model, the TCP IP model, which is favored. They are the equivalent in operation and both layered, but the OSI model shows more detail. Let me show you the OSI model real quick. So OSI model versus TCP IP model. So it's made up of the application layer, presentation and session, transport layer, network layer, and data link and physical layers, which makes up the OSI model. And that is the equivalent, and I'm gonna show you the equivalent. So the application layer TCP IP model in reference to the OSI model makes up the application layer, I think. Yeah, Zach is going to cover all the application layers in a bit. Applications are also known as software. Both transport and network layers are both the same for both models. Yeah, data link and physical is the equivalent to a network interface to the TCP IP model, or TCP network interface. Yeah. Go ahead, Ted.
Okay, so now we're going to talk about the application layer. The application layer is the topmost layer of the OSI model. And it is what most users interface with. It receives information from users and shows incoming data to the users. In simple terms, this layer provides services for end users' applications so that communication with another application on a different network is effective. Protocols used in the application layer include FTP, so File Transfer Protocol, HTTP, Hypertext Transfer Protocol, and SMTP. And then moving on to the next layer is the presentation layer. The presentation layer is responsible for formatting the data exchanged between systems to make sure proper encryption is used. Computers must make sure they're using the right format for compatibility. The presentation layer makes sure that a JPEG or GIF is sent across the network. It will be still in the same correct format on the receiving computer's end instead of just zeros and ones. This layer is also responsible for encryption, so it aids in securing data from prying eyes. Protocols included are JPEG and MPEG. And moving on to the session layer. The session layer, when computers or end devices need to talk to each other, aka send information, they need to set up a link or set. This is done at the session layer. There are certain rules defined at the layer that establish, manage, and terminate the connection between local and remote protocols in the session layer include NetBIOS or point-to-point tunneling protocol.
Alrighty. So Once we get to the transport layer, we call this data. And this is where the TCP IP header gets added, determining the software uses UDP or TCP. There's a bunch of details which we can talk about regards to the header, but I won't go into that in the presentation. The combined TCP and IP header with the data is called a segment. And applications that use UDP are music streaming services like Spotify or VoIP, which are used by phones. And applications that use TCP are email and web browsing. And next. Once we get to the network layer, this is where the network header gets tacked on. And now we call this whole thing a packet. The header contains IP addressing, which handles the packet routing via logical addressing. Source IP is like your home address, and destination IP address is where you want to send it to. Provide connectivity and path selection between two host systems. A layer 3 device would be a router. And I have like a bunch of routers in like below me. I can show you guys, but they're like really heavy. Next, we're gonna go to the data link layer. And this layer is where we tack on data link layer, the header, and trailer. The data link trailer is used to detect errors. Like the algorithm that is used is called CRC. It's placed here because the algorithm needs to access the whole frame. Just know here is where error is detected. The header basically contains source and destination MAC address. It is equivalent to your name, and a MAC address is a unique identifier of devices you are using. Like most humans, a device has a unique name. A layer 2 device would be a switch. And here's like a switch with like a bunch of ports. Yeah, so now we get to the physical layer. This is where the whole combination of headers and trailers data gets converted into ones and zeros, what we call binary. Giving you guys the purpose of what we learned about binary from our programming class. It's the language of machines. This whole process is called encapsulation, from layer 7 to 1, then goes over the wire to the end device. Once it gets to the device, it goes through the process of de-encapsulation, which means removing headers and trailers at the data link layer and headers from the data link / transport layer back to data. This data is then sent to the application where tasks are performed.
Okay, in conclusion, the OSI model is a theoretical stack of 7 layers. It is used as a reference to better understand how networks operate. Even though the TCP IP model is preferred model used by vendors, the OSI model today is still used in reference for troubleshooting. If you'd like to remember all the layers of the model, a good mnemonic to use is the all people seem to need data processing, which coincides with all the layers. And that is it.
There's our presentation. Here's our references. Yeah. Any questions you guys have for us?
I thought I had a question.
I'll take it.
Okay. What was my question? So do you see this OIS model replacing TCP/IP in any, or are they sort of in conjunction with each other? What's the benefit of it? I saw that there were more layers. That was true.
Yes. So when we reference the networking, we use the TCP/IP model, but using the OSI model, it shows a little bit more detail.
Yeah. It's
Okay.
like if you're gonna buy equipment from like a vendor, so if you're in a networking setting, like the all the manuals and stuff, I feel like would be using TCP/IP because it's a standard. If that makes sense. It's like, but usually the people working who are like the professionals, I feel like they would prefer the OSI just because, like Justin said, it has more detail to it.
Okay. So you don't make a choice, or who makes the choice to say, oh, I think we'll go with OSI versus TCP/IP?
It was just back in like what Justin said in the Department of Defense.
Oh, okay.
Was the ones or the ones who chose the TCP/IP as the most preferred one.
Yeah, I thought it was like a good opportunity to talk about networking during this presentation because we're going to be covering it in term 2 a bit. You know.
Yeah.
A little bit of inspiration to start learning this stuff early.
Yeah, and hopefully for term 2 you'll be back in at the college because there's a lab. We have 2 rooms that are the networking down on P3.
Oh yeah,
whatever they are.
I was in there last year.